Okay, so right now I want to talk about section 0.2, and that's going to be what we call real numbers. So there's a lot to talk about when it comes to real numbers, but we're just going to review some things that you should know for this class and maybe do a few examples that might help you just sort of brush up on things that maybe you haven't thought about for a while. Your suggested exercises are going to be 3, 11, 23, 31, and 33. Now, I'm not going to cover everything that the book covers. I would recommend that you flip through the section and make sure that it at least makes sense. But I just want to touch on a few things that students tend to have trouble with. So with real numbers, again, we're sort of meaning, decimal numbers where the decimal might have some repeating part. It might not repeat. It might go on indefinitely. It could be a decimal of just 0 in the case of like natural numbers or integers. So real numbers is just sort of anything that we think of as a number, without getting too precise here, that is not a complex number, doesn't have a complex part. So let's do a few simple things that people tend to have trouble with. Let's start with things that people tend to not have too much trouble with. But let's say I've got the number 5.1 and I add the number 3.2 to it. Well, then I'm just going to have 5 plus 3 is 8. The 0.1 plus the 0.2 is 3, and that's that. But now if I were to have something like, say, 5.7 plus 3.9, what happens? Well, I'm going to have to, and this is a decimal point, not a multiplication here. Then I'm going to have to do some carrying. Okay, so 0.9 plus 0.7 gives me 0.6. I carry 1, I'm going to get 9.6. Probably not a huge surprise to most of us. Okay, now let's do some fractions. So with fractions, sometimes people get a little confused. So I'm going to, again, start slow and get to a place where sometimes people mess up a little bit. So if I have a fraction like 3 halves, this means, I have 1 and a half. This is 2 halves plus another half. Okay, that's probably not particularly interesting to anybody. Let's look at another fraction like, say, 4 halves. 4 halves is, a whole plus another whole. So this should be 2, but one of the ways we like to get here is we say, well, this is 2 times 2 divided by 2, and we like to cancel these 2's. All right, well, that's fine. Let's do some more of this canceling. So the reason, by the way, that I'm talking about this is I frequently have people further downstream, like, people who are teaching junior and senior level science courses, saying, man, my students are really having trouble with adding fractions or subtracting fractions. So this is kind of a targeted review for that. So let's do something like 5/4 plus, let's do 6/7. So how do we add fractions here? Well, we would get into a little bit of number theory and say we're going to look for the greatest common the greatest common denominator of quarters and sevenths. That's going to be the least common multiple of 4 and 7. So what's the least common multiple of 4 and 7? Well, their greatest common divisor, they don't have their greatest common divisor is 1. So they're relatively prime numbers. They don't share any factors in common, so their least common multiple is just going to be their product. Now, if that was a whole bunch of just random words to you, then you should review this a little bit, but I'm hoping that at least most of those phrases were familiar. So I'm going to want to multiply the left-hand fraction, so 5/4, I want to multiply it by 7/7. So I'm multiplying it by 1. That does not change its value. And the right-hand number, I'm going to multiply it by 4/4. And I'm going to get 35/28 plus 24/28. And we're still going. We're not done yet. So 35 plus 24 is going to be 59/28. And for me, this is a good enough final answer. You can stop here. But the point is, as I'm doing this, I want to keep track of these denominators, and I want to find a common denominator. In this case, 28. Okay. So probably that's not something that you've never seen, but maybe it's been a while since you've actually added fractions. Let's get a little bit more annoying. So we talked about canceling. Let's do a little bit more canceling. Let's suppose that I have, let's say, 6 times x minus 2 divided by 3. How's that going to work out? Well, I know 6 is 3 times 2, so I can write 3 times 2 times this x minus 2, and I'll divide by 3. I can cancel those 3's, and I get 2 times x minus 2. This also goes by the name 2x minus 4. Either one of these would be a delightful final answer as far as I'm concerned. No big deal either way. But let's look at this. Let's look at a problem like this with just a little bit of a nastier setup. So let's look at 4x minus 12 divided by 2. Now I just want to say some people are going to look at an expression like this and say, oh, 2, that can cancel out of the 4. And I'm just going to come down here to the mistake area. This is a common mistake. Is people are going to say, oh, 4x minus 12. I can divide that 4 by 2, and I can divide this by 2, and I'll get 2x minus 12 or something like that. And this is a very bad no, please do not do that. That's a bad mistake. We don't want to be doing that. So what do we do up here? To do this correctly, we want to factor out the 4 first. We want to say 4 times x minus, well, how do I get the 12? It's 4 times negative 3. So 4 times x minus 3 divided by 2. And now, if I want to cancel, I write the 4 as 2 times 2, x minus 3, oopsie-daisy, x minus 3, and this is divided by 2, and I can cancel those, and I get, 2 times x minus 3. That's a fine answer. All right, so that's just a little bit about canceling. If you're having trouble, then look up canceling fractions. That's going to be something you're going to want to catch up on. So the last topic that I want to get into is going to be exponents and radicals or roots. So if I have something like the square root of 4, this is defined to be 2, even though, we have that 2 squared equals negative 2 squared equals 4. We're just going to say that the square root is the principal root, or the positive root if it exists, and the square root of 4 is defined to be 2. Now, 2 is a square root of 4. Negative 2 is a square root of 4, but when we say the square root of 4, we tend to refer to the positive one. Now, if you accidentally write square root of 4 equals plus or minus 2 on your paper, I'm probably not going to make a big deal out of it, but this is not the preferred way to do things. So what does this notation mean? Well, 2 squared means 2 times 2. Square root of 4 means what is the thing that when I multiply it by itself gives me 4. So let's break this down a little bit more. Let's look at, let's say, 2 to the 5th power. So now this isn't just multiply it by itself, but it's multiply it by itself 5 times. So 2 times 2 times 2 times 2 times 2. Well, that's 2. How many times? That's 5 times here. But it's not 2 times 5. It's 2 times itself 5 times. That's going to be 32. All right. Similarly, what if I have something like 125, and I want to take a cube root? So now I'm looking for the number that when multiplied by itself 3 times gives me 125. And what number does that? Well, that's going to be 5, and that's because 5 times 5 times 5 is 125. All right? So this, I can also write, an alternative notation for this is 125 to the 1/3 power. So that's the same as the cube root of 125. Oh, also, just a handy way, if you're dealing with this radical sign, a handy way to sort of mark off where you're ending is let's say I wanted to do the cube root of 125 again. I like to put this, and then I like to put a little mark there if I've got some other things following it. If I have the square root of 125 times some stuff, times happy face, let's say, this little vertical bar just kind of helps me know where the radical sign ends. That's just a sort of a side note. But now the thing that I want to end on is, what if I have something like 32 to the 3/5 power? So what's this going to be? Well, let's break this down. This is 32 to the 1/5 power cubed. All right, because 3/5 is 1/5 times 3. And we know that the 5th root of 32 is 2 because of this calculation up here. So we've got 2 cubed, which is 8. So this is, like I said, just a little targeted review on the real numbers from section 0.2. There's definitely a lot more in that section. I suggest you flip through it. But if you have any questions, of course, ask me. But this is just the kind of stuff that's in there. So again, you really want to look at sort of canceling with fractions. And you're going to want to look at, maybe if you're having trouble with adding fractions, you're going to want to look at factoring. So these are two things you might want to peek at. And then we've also got these exponents and roots to look at.